Okay, this is just a wee video on an introduction to set notation, which initially can seem quite complicated, but is actually quite straightforward. So if I do the first symbol that we need to get used to, it's like a kind of capital E. That means is a member of. If I do the same symbol with a line through it, that means is not a member of. Again, I'll explain these a bit more once I start looking at examples. Okay, and then we've got a sets of numbers that are defined and have been defined for a while. So first one to start off with is the natural numbers. Okay, now you'll notice what I've done is I've done an N, and then I've kind of got this slightly thicker line on the left hand side of the N, and that's just the natural numbers. The natural numbers is just any whole number greater than 0. And that just keeps going. Now, you'll notice I've put in these curly brackets. This is another part of set notation. That basically describes a set of numbers. So when you see these curly brackets, you're describing a set of numbers, and the set of natural numbers is any whole number greater than 0. Next one after that is the whole numbers. Again, the left hand side of the W has got that kind of double line. Again, using my curly brackets for the set notation. And that is just the natural numbers, all the positive whole numbers, but with 0. And obviously, the wee dot 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 means that it keeps going. Okay, keeping going with that, we've got the integers, which weirdly are denoted with Z. And that is the whole numbers plus negative whole numbers as well. Okay, and I should put dots in the other way as well. It obviously keeps going below -2 and above 3. After that, we've got the rational numbers, which weirdly is denoted with a Q. And that is basically any number that can be written as a fraction. Which encompasses a lot of numbers. But an example of a number that wouldn't encompass would be √2. You couldn't write √2 as a fraction. Okay, and the last set is R. This is the real numbers. And real is exactly what it says in the tin. It means it exists. So any number that exists, and that might sound a bit weird, a number existing or not existing, but for example, if you try and take the square root of a negative number, -4, square root of -4, if you put that in your calculator and check, it'll come up math error, and that's because that number doesn't exist. It's the same again if you had something over 0. So for example, if you put in your calculator 1/0 or 1 divided by 0, again on your calculator it would say math error because that number doesn't exist. So the real numbers is just any number that exists. Okay, so how does this play into kind of some examples? If I was asked to describe the numbers in this set, and again we're using the curly brackets, so x is a real number, that's what that means, it's a member of the real numbers, so it can be any number, and we're going to put a condition on it, so put dot dot, such that however that would describe any number between 0 and 3 that exists. So, for example, 2 would be in that set of numbers. 2.9 would be in that set of numbers. 1.3578 would be in that numbers. 1/4 would be in that group of numbers. Examples of numbers that wouldn't be very obviously 0. 0 wouldn't be in that group of numbers or that set of numbers because it's got to be greater than 0. And 4 wouldn't be in that because it's got to be less than 3. But it can be anything else apart from that.